So this is my EC4760 project. It is a 3D image scanning Lidar. Basically how it works is that this aperture right here, it has two servos, which an azimuth and an altitude, as well as a Lidar distance sensor. The point of this is that you turn the Lidar through a scan pattern and you get distance measurements. What that relates to is that you now have an azimuth angle, a altitude angle, and a distance measurement, which is polar coordinates. You can use that to create a Cartesian point, and if you take 20,000 of them, you start getting a actual 3D image out of it.
So show me the 3D image that you just accumulated.
So this was run maybe 2-3 minutes. You can see it's of the same scene over there. So you can see that there's a T-strut right here. You can see that there's, if you look on the top, you can see that there's 4 distinct distances away of walls. And that's the door, the crack between the cabinet, and then the wall.
So there's the door, the cabinet, the crack between the cabinets and the wall, and then the star.
You can also actually see the trash can. You can see that there's a slightly rounded section right here. And that actually correlates to, that's right in front of the cabinet, which if you look over there, that is right where the trash can is.
Okay. Why don't you run the scanner?
Sure. So I'll show you, I won't collect points, but I'll show you what it looks like. So it outputs two different things. It outputs to 3 UART Cartesian points to my computer, which I can then turn into this image. And also for debugging and also real time, it displays a distance map to TFT. TFT basically displays, it takes in the 2 ADC angles, converts them to X and Y positions on the TFT, and then the color is based on the distance.
Okay.
Very close is blue and very far is red. You can turn it on. It'll take about 3 seconds so it can go through that. And then you can start seeing the scan pattern. So it goes slowly off frequency for the azimuth and the altitude. The reason of that is so then you get the full scan instead of just reiterating the same points over and over and over.
And this would be an alternative to a straight raster scan, for instance.
Yeah. So you can seeing that the blue is the table that's right here. You can see the
strut in the middle.
You see the strut, the teal, and you can see the black to the left and right are the windows. Left and right of the strut. And if someone,
and meanwhile, we're streaming data over here into the.
So the PCD file is just a header, and then it's line of 3 floats X, Y, and Z. And that's as simple as it is.
Very good, very cool. And this board is.
This board is for power, so it connects the servos, the signal sent from the board to the 2 servos, as well as the Lidar sensor output. So you need to send a varying PWM signal that goes from a varying length to get a triangle wave, and that's what produces the scan pattern. And also you can see there's heavy capacitors to try to isolate it, as well as opto-isolators to try to stop any heavy noise.
Okay, and then the main board has the TFT and also a PIC32 on it, and a heartbeat LED just to make sure, so you can see the threader is working.
And then, I don't know if we talked about this, these 2 white lines on the feedback. That's what I'm using to get the actual reading for azimuth and altitude. And it goes through, they will each go through their own differential amplifier to amplify the signal. If you don't amplify it, then the raw feedback signal is only between 1 volt and like 1.7. I didn't want to waste my ADC units on trying to decipher that, so I use a differential amplifier to kind of increase my precision, so I can see with finer granularity the angle.
Okay, cool. Thank you.
No problem.